So let's solve the following inequality. Again, notice how this is a polynomial. It's a third degree polynomial this time. So again, our strategy is to set this to 0. So if we set x cubed minus 7x squared equal to 0, we can find the zeros. Notice that it is factorable because there is a common factor of x and they have two x's in common, so I can actually factor the x squared out. If I pull out an x squared, so I'm going to divide an x squared out, which leaves me an x there. If I divide the x squared out there, or factor it out, if you will, that's just going to leave me a minus 7. So if I set each one of those equal to 0, I have x squared is equal to 0, which means x is going to equal 0. If I set x minus 7 equal to 0, we have x equals 7. So notice how, since this has a degree 2 here, this has a multiplicity of 2. I'm going to just use the m for multiplicity, which means this kind of what we refer to as touches and turns, if you will. So it doesn't cross, it just touches and turns back up. This is a multiplicity of 1, so it's going to cross. So remember, if the coefficient of x cubed is 1, our graphing behavior, as far as end behavior goes, is it's going to finish high over here. It's going to do some stuff here in the middle, and it's going to finish low over here. So that's all I'm really interested in. The end behavior is dictated by this x cubed. So it's going to have this finish over here and this finish over here. So what I can do is plot the zeros. So 0 is the smallest one, and the 7 is the bigger one. So if I look at graphing behavior, the graph is going to finish low. And when it comes to the 0, notice how it's a multiplicity 2, so it's going to touch and turn back around and go down. Then it's got to turn back around somewhere along the way. When it gets to the 7, it's actually going to cross. It's going to go on across there. Now, since it says, since the inequality says less than 0, this has got to be negative. So if I look at my behavior, since it's, again, we're treating this like the x-axis, this is down below, and then we can't be there, and then we're down below again. These are all negatives. And then you can't be there either, and then you are turning into a positive there. So as far as the solution goes, it looks like we have two intervals where it's negative. So from negative infinity to 0, it's negative. In union with, again, we are also negative between 0 and 7. So in union with 0 to, to a positive 7. And then once you get past 7, it's going to be positive. So that would be the two intervals that we're kind of seeing. So again, if I want to use the calculator, I could verify that as well by graphing it. So I have x cubed minus 7x squared. If I graph that, you can kind of see one of the zeros is 0, and the other one is 1, 2, 3, 4, 5, 6, 7. Notice that the graph stays below the x-axis until you get to 7. Now, if I want to see more of the graph, I'd have to really make my handle move down more negative. So I'd have to probably change my y-min to be maybe like a negative 100 and see if it makes a difference. In doing so, I may want to make my scale go by tens. If I graph it again, yeah, that helps us see that the graph does, that's how it finishes low to start with, touches, turns again, and crosses. But notice that we're seeing that it stays below the x-axis through here. We can also see it from the table perspective. So if I look at 0, let's go the other way, 0 is the other way. Notice that 0 is 0, but if you go left to 0, notice how it's negative. It stays negative. Notice how the y values are really taken off. They're not coming back. If you go the other way, notice that if you're between 0 and 7, notice how you're still negative as well. But once you get past 7, notice that the y values do turn to positive values. So you can kind of see it that way as well in the table. So see how 7 is a 0 because the y value is 0. That's what makes the function 0. And 0 makes the function 0. So those are again called your zeros. So that looks like we've got the correct answer there. So again, since it's less than 0, we cannot include the endpoints. So they're open with parentheses.